All right, good morning, everyone. So let's continue working on internal forces and moment diagram. In this problem, you have a beam, a cantilever beam, and that is loaded with distributed load that has height 600 Newton per meters. Okay, so now let's by making a free body diagram. So this is the distributed load, right? And the length is 4 meters. Total length is 8 meters. At point A, we have this what we call AY. This is AX, and this is MA. Yeah, this is the reaction moment. Okay, so this is 4 meter, and this is also 4 meter. I think it's complete now, right? In case it's a free body diagram. That's how you draw the free body diagram. Okay, and now what you need to do is to make sectioning to find the reaction forces. How to get that is basically by sigma fx equals 0. It means that ax equals 0, yeah, because ax is the only forces that works in x direction. This is x, this is y, yeah, okay. And then you can check also the sigma fy equals 0, and then you have ay, which is positive, and then you have 600 times 4, yeah, and then that's negative 600 times 4, yeah, so that's the equivalent forces, and it should be located somewhere here, right in the middle, right, and then 600 times 4, yeah, and there are 0 equal to 0, so your ay is 2400 Newton, okay. And then let's make it in green box, so we know that this is the solutions. And then let's find MA. Sigma moment at A equals 0. So you have minus MA because MA itself is clockwise, so it's negative. And then you have this 600 times 4, and then multiply by 6 meter, right? And they are equal to 0. So your MA will be equals to, how much is that? 24 times 6. So minus 24 times 600. And that equals to, let's calculate 24 times 600. So this is Newton meter. Okay. That is your moment, reaction moment at point A. Okay. So now you got all the reaction forces, right? What we need to do is to make a sectioning. We need to do two section. First section will be done here, I guess. All right. Second section is within this. Okay. So let's draw the first sectioning. And the first sectioning valid if x is from 0 to 4 meter. Yeah. And then you have this ay, you have ax, you have ma, and then you have v, n, and m at sectioning point, and then the location of the sectioning, we call it x, right, where x is the variable from 0 to 4. So if you check n sigma fx equals 0, your n will be become ax minus ax and then become 0, right, because x is 0. And then sigma Fy equals 0. You will have Ay minus V equals 0. Your V will become Ay, 2400 Newton, right? And let's make it box in grains. And then sigma moment at the section endpoint equals 0. So you have this minus MA, and then you have plus M, and then you have this AY. AY also clockwise, so it's negative, right? Minus AY times the distance, which is X, yeah, equals 0, and then your M will be MA plus AYX. And then if you plug everything, your MA is minus 14,400 plus AYX. AY is 2,400 X. Okay, and that is your moment, internal moment. Okay, so if you take derivative, this should be equal to this. And then they are checked, right? Because we know that V is dm dx. So if you take derivative this with respect to x, you get the exactly correct results. So it means what we are doing is correct. Okay, and then let's do the second sectioning. Yeah, second sectioning, we make section here. Yeah, so let's draw it like this. You have AY, AX, MA, yeah, and then from here to here, you have distributed load, and from this distance to here, let's call it X, yeah, and then from this distance to here, the distance is 4 meters. So means that this distance is X minus 4. And this analysis that we are going to do, valid for X 4 to 8, yeah, 4 to 8 meter. Okay, so to make it easy, this distributed load can be found this equivalent concentrated load, that is 600 times the length X minus 4, yeah, and they're located right in the middle, yeah, and then this will create V N M. Okay, now let's do it again. Sigma Fx equals 0 and also 0. Yeah, this is classical because X is 0. I don't need to explain more. And then you need to find sigma Fy equals 0. Here you have a lot. You have Ay. And then you have minus 600 X minus 4. Yeah, because the height is 600. The length of the distributed load is X minus 4. Yeah. Am I right? Yes, you're right. Am I right? I'm right. And then minus V equals 0. Yeah, because this V. Is there any load? No, only AY, 600, and then V. Okay. And then my V will becomes AY minus 600X plus 2,400. Where is AY? Where is AY? AY is 2,400. So AY is 2,400 too. So it's 4,800 minus 600x here. That is my V for the second section. Okay, now let's do sigma moment at sectioning equals 0. Yeah. The first moment MA is negative because it's clockwise. And then the second forces that create moments also negative AY times the distance from AY to the sectioning point here, which is X, right? And then do I have another forces that create moments? Yes, that 600 will create positive 600 x minus 4, and then the distance is that x minus 4 divided by 2. Am I right? Yeah. And then that's m. M is plus, right? This plus m equals 0. My MA will be, what is MA? MA 4,000 minus 4 minus 14,400 minus AY. AY is, where's my AY? Oh, 2,400 minus 2,400 x plus 300 times x squared minus 8x plus 16. M equals 0. 14,400. Yeah. Sorry for my writing. Sometimes I put, yeah, I hope you understand. Minus 2,400 x plus 300 x squared. And then I have minus 2,400 x. And then I have 4,800. Am I right? Yes. Plus m equals 0. Is there anything I can cancel? And then my m will become, let's delete this. 3, 3, 3 m I have. Is this 404? 14,400 divided by 300. Okay. So divided by 300, this becomes 1. This becomes 8. This becomes 48. This becomes 8. This becomes 16. But anyway, I cannot, oh my, there's no 300 here. So I cannot erase. Okay, anyway. Yeah. X squared. Let's do it like this. 300 x squared minus 16x plus x squared minus 16x plus 16, 60, 58, 64. Yeah, 64, right? And that is m. And it should be minus here. Yeah, this is my m. Let me take the derivative of this. 600x plus 16 times 340. Okay, yeah, it's correct now. So this is my moment equation. If I take the derivative this, v dou m dx, that should be this, yeah. because this become 2 times minus 300x, which is minus 600x. And then this, if I take derivative, minus 16 times minus 300. So plus 4800. So I'm correct. Yeah. So this is how you get the equations. So if you want, you can make V M, okay, and then this is X, 0 to 4 and 4 to 8. Your V is 2400, and then this one, the moment will be, okay, and then here my V will be 4800 minus 600x, and this becomes minus 300 x squared minus 16x plus 64. Okay, and then you can draw this if you want at x equals 0. So this is from 0 to 4. Yeah, this is 2400. Yeah, 2400. If it's 6,200 and then 8, 0, am I right? It will become 0 like this. This is V, and this is X. Okay, and then this is M. The first one will be, if X equals 0, they will become minus 12,000. Okay, X equal 4, 8,000, 9,000. Let me calculate. Minus 4,800. Okay, and then the moment at x equals 4, 4 times 4 minus 16 times 4 plus 64 times 300. Okay, and then if x equal 8 times 8 minus 16 times 8 plus 64 becomes 0. This is 0, but it shouldn't be straight line. And at x equals 6, let's say 6 times 6, 16 times 6 plus 64. Am I right? 1,200. Yeah, maybe something like this. Okay, and here is minus. Okay, this is the force and moment diagram for V and M. Shouldn't be difficult, it's just that it takes a long time. Okay, and for my record, it takes like 21 minutes, I guess, yeah, to solve these problems. And the most important thing is that you need to know how to make this, yeah, x4, so it's x minus 4. So how to make distributed load because becomes equivalent concentrated force 600 times x minus 4. Why? Because this length is only x minus 4, right? That's the most important thing, I guess, in this whole thing. And if you want to recheck again, you can recheck by taking the derivative of m. You should get back to the v. Yeah. So if you take the derivative of this m, you will get 2 times minus 300 times x, and then you will get minus 600 minus 300, yeah, and then you will have minus 600x plus 48 hundredths, and this is what it is, right? So they're correct. Okay, that's how you verify whether your algebraic calculation is correct or not. Okay, I hope it's very clear. Yeah, so you just need to review one by one, step by step, and I think it should be easy. Practice a lot, practice a lot, practice a lot. That's one way to excel in these courses. Thank you very much.